Okay, hello to everyone here. My name is Zheng Yi and here is my final year project 1 presentation video. So thanks for your time and attention in advance. Okay, I'm gonna start now. The project title is Speech Emotion Recognition by Using Deep Features. Here is the content. I'm gonna explain by sequence: introduction, statement of problem, objectives, literature review, methodology, analyze and design, technical implementation, and references. As we all know, we talk to people every day for communication, right? Imagine that a man is standing 5 meters from you. You may think it's too far, that he cannot clearly hear you, so you shout at him. However, that man, he received your message and thought you are angry because you are shouting, while yourself is just think, I'm talking to you, I'm not angry, I just talk normally. That's why detecting emotion from the speech is really important for understanding their emotions. The most challenging part of building a speech emotion recognition system are the 3 points. First one is the type of the features that extracted from the speech file. Second is the classification. It depends on the classifier you choose. And third one is the accuracy problem. So after we learned the problems above, we know that human emotional state is a very complex nature. So it's hard to complicate in terms of feature selection and classification. So we need to have a better selected feature and a powerful and faster classifier. For example, we can use deep learning, support vector machine, and k-nearest neighbor. Generally, researchers have did a lot of work trying to improve speech emotion recognition system because the high demand of using it in many practical applications. And about the database, Able is most common used. It's a literal dataset, and the others like Berlin, Survey, and etc. are also can choose depending on your demand, but they are recording for research purpose, so it's not as literal as the Able. And the feature extraction, simply say, it's a process of dealing with the raw data and make it easier to management for processing. Now we are using MFCCs, LPCCS, and PLPS, and deep features also used a lot. And for the classifiers, there's also a lot of categories. We have supporting vector machine, hidden Markov models, neural network, k-nearest neighbor, and Gaussian mixture model. So here's the methodology that we achieve our system. The first one is database. In our work, we used Berlin database of emotion speech, which contains of 535 samples. So it was 10 speakers, like 5 men, 5 women. They act in 7 different emotions, which is happy, angry, anxious, fearful, bored, disgusted, and neutral. We divided the dataset to train and test equally. Thus, thus it's easier for me because we do have more efficient classifications like cross-validation, speaker independent, but it's hard to achieve. So maybe we'll apply it into next stage. And second, for the feature extraction, in our work we used 32 deep features that extracted by deep neural network. So in a deep neural network, it receives a speech signal and give us emotions as an output. We choose the last hidden layers from the deep neural network. So these features are a set of data that haven't completely done. And third is k nearest neighbors. In our experiment, we used one nearest neighbor as classifier. It's quite simple, but very powerful. Like in this diagram, in the distance, only red one is inside there, so we categorize this as a red. Okay, next we are going to analyze and design our system. So firstly, we use the deep learning model from MATLAB website. And after run and test, we found that the extract feature took a lot of time, and the test and train process take more than 10 minutes. And the accuracy is 81.6. So I'm wondering, this time took it so long. Can we make it easier? Can we make it shorter? And the accuracy can be improved. So here's my solution. So first, we extract 32 deep features using deep neural network. And then, by using one nearest neighbor, we can get better performance. So in our model, we get an accuracy of 81.7, which is a little bit better than 81.6. And third, the timing of use deep learning model is very long, as I mentioned above. When we are using a deep feature, we extract first, and then we just use one nearest neighbor for train, and it takes less than 1 minute to get the output. So the design process is, we get the dataset. Among these two experiments, we use the same dataset, which is Berlin database of emotional speech. And second, we extract the feature by using deep neural networking. And then we use the one nearest neighbor MATLAB code to run the model. Actually, there are many classifiers, but one nearest is simple but very competitive. It's easy, but it's high efficient. And next, we get the result and analyze it. So here is the method architecture, same as the design process. And next, we are going to implementation stage. The first step is extracting features. We got 32 deep features for each speech sample by using deep neural network. So here, the first column is the label for each sample, and the other 32 column is the feature have been extracted. And after training, we got to a CSV file, a train set with 267 samples and a test set with 268 samples. After the first step, then we write the code and use the one nearest classification to run the sample data. And then we got the output. This should be the accuracy at the error rate equal to 1, because I changed here, so this should be accuracy. This is the output for using deep learning model, the example from MATLAB website. The accuracy is 81.6. So we make a compare. Both use Berlin database emotion recognition set. And for the time, one nearest neighbor model take less time, while deep learning model really take a much more longer time. And for the accuracy, deep learning model is 81.6, while one nearest neighbor model is 81.7. However, so we can see that the accuracy didn't improve much. So we want a better accuracy and a faster training progress. Maybe we'll try using k nearest neighbor or support vector machine next time to get a better performance. And that's all for it. Thank you.